Great, so let's go ahead and build this chart now using rectangle glyphs. So how is a rectangle defined? Well, when you use the rect method from the bokeh.plotting interface, what you pass to the rect method are 4 mandatory parameters. So the first parameter is the x coordinates of your rectangles. So if you have one rectangle in your entire plot, as the first parameter you'd have to pass the x value, so which should happen to be somewhere here. If you have more, so we have, let's say 8 here, 8 rectangles, we'd have to pass a list with 8 x values. And then you have to pass the y values, which as you may understand is the value of this y-axis, and then you need to pass the width, the horizontal width, and the height. So that's how you define your rectangle. And so you can pass lists when you have lots of rectangles like we have here. You can pass lists, or you can pass data frame series or data frame columns, in other words. So let's do that. p.rect, and the x-axis is, well, the date time values where close is greater than open. You know, if you start comparing this rect method to the quadrant method, if you use quadrants and you pass the date there, your quadrant would start here at this axis. But normally the central axis of a box in candlestick charts starts at the very day, and then it spans 6 hours left and 6 hours right. So for quadrants you would also have to do a trick there. So you'd have to subtract like 6 hours from this date here, so that you end up with this kind of position of your quadrants. But for rectangles we don't need to do that, because we immediately get the center of the rectangle with this method. So that's the x-axis, and then you've got to pass here the central y coordinate of your rectangle. So what we know about this rectangle is the closing price here and the opening price. So that brings us to the point that the central axis here would be like close plus open divided by 2. So df.open plus df.close, so that would need to be inside brackets here, divided by 2. And that's how we define the y coordinate. Now we need to pass the width of the rectangle, so which happens to be always 12 hours. So how do we pass 12 hours there? Well, this chart, this plot is designed to accept milliseconds for values along the x-axis. So we have date time here, and this accepts milliseconds. That means we need to convert the 12 hours into milliseconds. And I can either calculate those seconds and pass the final number directly here, or I could do something else. You know, if I open this code in a later time and I've forgotten some things here, so to make it more readable, I'll probably create a variable here and store that number in these variables. So let's say hours 12, so 12 hours, that would be equal to, well, 12 hours times 60, we get minutes, times another 60, we get seconds, and then we want milliseconds, so that would be 1,000. So 1 second has 1,000 milliseconds, and then that means I can pass hours 12 in this third parameter, which is the width of the rectangle. And then we have the height of the rectangle, which would be the difference between the opening and the closing price. So df.open minus df.close. Now sometimes you get negative values here, so you need to think about when open is higher than close, or and vice versa. Or you can just pass apps here and you will be alright. So whether open is higher than close or the other way around, this absolute method apps makes sure that you always get a positive value out of this, which will be used as the height of the rectangle. And now what I could do is I could add the color that will fill these boxes and the line around these boxes. But before I do that, I want to make sure I have everything in place. So I want to output what I have so far. Output file. Let's call this candlestick CS for short. .html, and then show the figure is stored in P. So show P. Execute this and see what we get. Yeah, not bad. So let's check one of these. So for 1st of March we have from 704 up to 718. 1st of March here. Yeah. And then day 2 and 3 of March do not exist here. So day 2 and 3, they are not there because close was less than high for these dates. And here we are filtering out the data frame rows with this condition. So that's why we don't have these candlesticks. And this is weekend. So we don't have data for this, but we have the ticks in the x-axis. So, and let's pass the fill color. So let's say green, and the line color black. And now the line here is getting long, so what I could do is I could break this line into 2 parts, but make sure if you do the same, make sure you break your line after a comma. So you can break it here or here or here, but if you break it here you'll get an error. So, and try that again. So we have green candlesticks now. Let's quickly go now ahead and copy this and paste it there. So what I want to do in this case is I just need to change this operator here. So in this case you want to plot the candlesticks where close is less than open. So this will be the x coordinate for the center of the rectangle and the y coordinate, which will be the same. And width is 12 hours, so this number here, and then the height the same, and the fill color will be red for these charts. So for this it means that the day open with a higher price and then it closed with a lower price, so that which means that the stock price went down throughout the day. So let's see. This is what we get, and we'll have to remove these horizontal grid lines later. So for now let's focus on the result. Now this may look good, so your script didn't stop and you may think that everything is okay, but what you have to do is whenever you're building some graphs or some outputs, it's good to get some samples out of that output and check it with your source data. So in this case, for instance, we have this second glyph here, which starts here and it ends here. But if you look, and so this says for day 2 of March, but if you look here, you'll see that day 2 starts with an open of 719 and it closes at 718, so with just one value in difference, which this one here looks more like the second row and not this. The reason is that here in the first rectangle we passed this filter index, so we got only the dates where close is greater than open. But then if you didn't realize that, I didn't pass this filtering in the y coordinate, so that has messed things up. So Bokeh is grabbing the first date time for the filtered date time index, and then it gets the first middle value of close and high, and then it gets the second and the third, and then you end up with this wrong glyphs. So what you have to do is you need to filter out the open and the close columns too with this condition. Now you can do that here, but what I would suggest, and that's the reason that I left this unfiltered, so I wanted to get to the point that it's better to actually write some intermediate code. So what do I mean by that? For instance, in this case we filter the data frame column on the fly, so inside the rectangle function. This is good because you end up with less lines of code, but you lose some control over your script. So if something wrong happens there, you don't know, and you end up with these kinds of results. In that case, what I would suggest is actually create some intermediate results. So for instance, in this case, what I could do is I could store this filtered date time into a variable, let's say date increase. So when we have an increase there, that would be equal to that, and when you have date decrease, this has to be like this in this time, and execute that and try them out now. Date increase, you get this filtered panda series. So if you check the type of this, you'll see that this is a time series. So similarly, you can check your other variable decrease, and so you get 2nd of March, 3rd of March, so 2nd of March, 3rd of March, where the closing price was less than the opening price. So these two values here. Then you'd have to pass these values to their corresponding places in here. So for the green boxes, you'd have to pass date increase, and then here date decrease. So passing series. That's one way to do that. Another way, which I'd like to show you how to do, is to probably create a status column in your data frame. Then you'd have like different strings. So you'd have two strings, an increase text or string, if you like, increase text if the closing price was higher than the opening price for that particular row, and then decrease if the closing price was lower than the opening price. And then we can extract the date column out of the data frame by applying the condition that if the status column value is equal to increase, give me the date for that particular row. And then if it is equal to decrease, then again give me that particular date for that row. So that's a more standard way of doing things. So I'd like to do it that way. So let's say df status. So we're creating a new column of the existing data frame. And then we could do a list comprehension there. So we could create a list on the fly. So we'll say something like, give me increase if or close is higher than open, or decrease if close is less than open. And we can write that statement inside here, or you can create a function that generates increase and decrease depending on these values on the close and the open values. So let's say define increase, decrease, let's call it like that. And here we would have to pass two parameters, so you need to pass the value for the close column and the value for the open column. So if C is greater than O, let's say value will be equal to increase. If C is less than O, value will be equal to decrease. And maybe we have the very rare occasion where value will be equal. So if close is equal to open, then we'll have, let's say, equal. And then what you need to do is return value. So make sure you are outside the if conditional here, but inside the definition of the function. So df equals to status, and we would have co for co in zip, df.close, df.open. So let me explain this. What this is doing is, it says that for the first value of the status column, assign the value that this function returns. So we're passing there the C and the O variable for these variables in these columns. So what this will do is it will go through the next row of the data frame, and it will pick the close value and the open value, and it will assign the close value to the C variable and the open value to the open variable. So this will have the values of around 718 for C and 703 for O. And so these values will be passed to this function. So you would have like if 718 is greater than 700, then assign the value increase to the value variable. And then at the end of the function you return increase. So you return the value, which is increase in this case. So this thing here turns to be the string increase in the first iteration. And so the list will get the value increase for the first iteration, and then in the next iteration it will get decrease, and so on. And so you get a list of increase and decrease strings, and that list then becomes a status column. So I hope that is clear, and I'll execute this and print out the df data frame, and here we go. So increase for the first, decrease, decrease, and then the three last ones are increase, because the closing price is higher than the opening price. That's it. And now you go ahead here and you don't need this anymore. What you need is df index, of course. So you want the dates where df.status is equal to increase. And again here we need to delete this. df.status equals to decrease in this case. So that's about the x-axis of the rectangles. So this one here. Now we need to define the y-axis, which is the middle price. So open minus close divided by 2. And as I mentioned earlier, it's good to have intermediate results. So for these two we will do the same thing, more or less. So we need to create another data frame column, let's say middle. So that would be df.open minus df.close, and this goes inside brackets because we need to divide the entire expression by 2. And so if you execute that and then print out the data frame, you'll see a middle column there, which would be, oh yeah, we got some funky numbers there because I had to sorry, add that. So df, yeah, this is the average between open and close now. Great. Now what we could do is, in here we access the middle column values, but again with a condition. and the condition is status equals to increase. And the same goes for the other set of rectangles, but this would be decrease. So that's great. And we also have the height here, so we need to filter this out too, because we have two different sets of rectangles. So again, we go here and say df height equals to the absolute value of df.close minus df.open. So that should do it. Execute the data frame, and we get the height. So 15, which means 18 here, minus 3, you get the idea, is 15. And then we go to our candlestick chart. So we need to replace this with df.height with where status is equal to increase. And same thing for the other set of rectangles, and decrease. Great. Execute. And we have an error, invalid syntax there. I seem to have passed an assignment operator, which is different from the equal operator there. And where is that? It's here, this one. So one more. Execute again. And so here is the updated chart, which looks different from this other one. So now we get this short rectangle there. Let's check this one as well. So the first, second, 3rd of March. They start somewhere at 719, 712. So the 3rd, yeah, it's somewhere at 718, 712. So it's looking good. And I'd like to stop the video here, and in the next lecture we'll go ahead and make this plot area more visually appealing. We'll remove these grid lines and also add the segments. So I'll see you later.